Hey everyone, today I'm pleased to present a reach calculator. What this calculator does is give you a set of equivalent focal lengths on various sensors that all give you the same number of pixels on your target. Now, it's important to note that this is not related to field of view. Field of view simply represents cropping, and cropping doesn't give you more detail or more pixels on your subject. So let's see how it works. I programmed it by hand without using AI, and you can access it in the link in the video description or in the comments. All you do is select the sensor you're using, and I've provided some example cameras here. Type in the focal length on that sensor and type in the maximum aperture too, so you can take into account low light performance and depth of field. To get the result, click Calculate. Now let's do some examples. Alright, some famous ones that have caused a lot of internet arguments. The 300mm f4 on 20 megapixel micro four thirds. How much reach does it really have? Here it is, the results. Now, what do they mean? For example, on a 45.7 megapixel full frame camera like the Nikon Z8, you would need 388 or about 400 millimeters to get the same number of pixels on your subject. That means if you took a 388mm lens, put it on the Nikon Z8, then cropped to 20.3 megapixels with a 4/3 aspect ratio, you'd get exactly the same shot with the same number of pixels on your target. It's important to note that you wouldn't be cropping to the micro four thirds field of view though. No, only to the number of megapixels or 20.3. Let's do another. Now we'll see what sort of lens is required to produce the same number of pixels on your target as a 600mm f4 lens on 45.7 megapixel full frame. Alright, you would need, for instance, a 413 or about 400mm lens on 25 megapixel micro four thirds. Keep in mind that this means that if you had a 413mm lens on 25 megapixel micro four thirds, took a shot of a bird, and then you took a photo of that bird with 600mm f4 on 45.7 megapixel full frame, and then crop that shot to 25 megapixels with a 4/3 aspect ratio, then you're going to get the exact same shot as a micro four thirds camera in terms of total number of pixels on your subject. In terms of depth of field though, you would need that 400mm lens to be an f2.8 lens. And what's more, you do have the opportunity with the wider field of view on the larger sensor to move in even more to theoretically get the same framing and get even more image quality. However, in practice, that's sometimes limited by minimum focus distance. So what does this all mean? Well, in summary, I can say that there are really only three ways to get more detail and more pixels on your subject. The first is getting closer to your subject. That's more important probably than even focal length and more pixels, because getting closer gives you less atmospheric disturbance and it will give you more image quality pretty much all the time. There's nothing like getting closer to your subject. The second method, and much more important than pixels again, is focal length. Using more focal length is much better than just using more pixels. But of course, if you have a focal length limitation and you can't go closer to your subject, then adding more pixels does give you a little bit more detail on your subject. But field of view does not give you more detail on your subject. It can't give you more pixels on your subject. Field of view is just cropping. If you're using a smaller sensor, it's like cropping a larger sensor. And if the pixel density of that smaller sensor is a little bit more than the larger sensor, you are getting a little bit more pixels on your subject with the same focal length. But a lens like a 300mm lens on a camera like micro four thirds is not going to give you the same amount of detail as a 600mm lens on a high pixel density full frame camera. So I hope you enjoy this calculator. You can go in and input whatever focal length and aperture you want just to get an idea of how different focal lengths compare on different camera sensors in terms of pixels on your subject. Hopefully that subject is birds. Anyways, I hope you enjoyed this video, and I'll see you again next time.